Hi everyone. In this video, we'll go through 1 mark questions related to mathematical logic. So let's go through this list of questions one by one. Negation of P conditional Q. What is negation of P conditional Q? So we'll have to remember all the De Morgan's laws, associative laws, distributive laws, negation laws, right? Very important. We'll have to remember the negation laws. There are negation laws for conditional operation, for AND operation, right? For OR operation. So we'll have to, and also for biconditional, right? We'll have to remember those negation laws. Now, negation of P conditional Q is, what will happen is this conditional will translate to AND, right? It will become conjunction, right? And what does negation means? It will be actually like this. This is not of P conditional Q, right? Now, what will happen is, you will not put negation for P. You'll just put P like this. And instead of conditional, it will become and you'll put not for Q. You have to remember this law. So now here, what will happen? You'll put P and not Q. So P and not Q is the answer. Next one, negate the proposition, this particular proposition. Now here, what does negation mean? You'll have to put not and put the entire proposition inside like this, right? This is negation. Now you have to simplify this. So here what you'll do, not of not P. What is not of not? It will get cancelled. So it will be P. And instead of this and, it will become or. And not Q. It will become not Q. Like this. So this is the answer. Next one, negate this proposition, right? Now here it's a conditional operation. So whenever it's conditional, it's going to become and. Remember one thing, whenever it is conditional, it's going to become and. And so what will happen is, actually it will be like this, negation of P conditional Q. Now what will happen is, this particular first term will be as is. It will not have any effect on negation. Whatever is there in the first term, right? You have not P, so keep not P as is. And put and symbol instead of conditional. And for Q, you'll put not symbol. For Q, you'll put not symbol like this. So this is the answer. Not P and not Q. Next one, negate the proposition when you have something like this. Now this means negation of, right? You need to remember this negation. You'll have to put not here. Now how do you simplify this? So here only in conditional you have to put and. When you have something like this, reverse it. What is reverse of, this is or. What is reverse of or? It's and. So it's like this, right? The symbol is going to become reverse and. Now you have to take not and not P. Not and not will get cancelled. So you'll have to P. Not of Q. This is the answer, right? P and not Q. Very important formula, right? You'll have to remember, not of not P is always P itself. Because not and not will get cancelled, right? Not and not will get cancelled. Next one, find the truth value of P conditional not Q. If P is true and Q is false. Now, what you'll have to do, P is true. So, instead of P, I'll put true. Conditional, Q is false, but it's not Q. That is not false, right? What is not false? Not false is true. So, true, conditional true. In conditional truth table, you'll have to remember this. True, 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 false, false, true, false, false. So in conditional truth table, you have to remember this odd combination. What is the odd combination? When P, that is when first proposition is true and second proposition is false, then the result is false. Everything else is true. Only this particular odd combination, when first proposition is true and second proposition is false, then the result is false. Now here you have T conditional T, that is true conditional true, this first combination. What is the result? Result is true. So answer is true. Now next one, negate the proposition. 4 is an even integer. This is one proposition. 7 is a prime number, another proposition. How are these two propositions connected? With or. Right? Now what is the or symbol? This one, right? Symbolically you'll have to represent this first. So it will be P or Q, or P disjunct Q. P disjunct Q, right? Now it's better to remember as P or Q, right? Now I have to negate this. That means I have to put not symbol here. So negate it means what I'll have to do? Not of P. This will become not of P, not of Q. What is the symbol? It will reverse. It will reverse. So it is or, it will become and, like this. This is the answer. If just written it in symbolic form, we will have to write it in verbal form, right? So not P, that means 4 is not an even integer. Not 4 is not an even integer. And instead of or, it became and, because we have and here. Not Q, that is 7 is not a prime number. You're putting and, you're putting not and not. Next one, symbolize the proposition. So you have two propositions given. 2 plus 5 is equal to 6, or all integers are rationals. So you take this 2 plus 5 is equal to 6 as P, all integers are rational as Q, and you have or, this one, this symbol. That's all, P or Q. Next one, symbolize the proposition. If oxygen is a gas, then gold is a compound. Now, first thing is, how do you split the propositions, right? You should never include if, then, or, and. Those should not be included. So oxygen is a gas. You should just consider oxygen is a gas. This is one proposition. Then gold is a compound. This is one proposition. Don't put if and then, right? Should not put if and then. So if and then, what does if and then means? It means conditional. If then means conditional, arrow. So it will be P conditional Q, because it's if then. Next one, symbolize the proposition. If quadrilateral is a square, then it's a rectangle. Again, quadrilateral is a square is P, it's a rectangle is Q, it's connected with if and then. So it should be conditional and P conditional Q. Next one, symbolize a proposition. You have y plus 4 not equal to 4, or E is not a oval. Now this is slightly tricky. Carefully watch this. Okay, it's not equal to, here also there is not, right? You have to observe this. There is not and not. Whenever you are putting propositions, it should be positive. That is, you should not have a not, right? So I will say let P is equal to y plus 4. Let P is equal to y plus 4 equal to 4. This is my first proposition. Second proposition is E is a vowel. Don't put not. In both the cases, you should not put not, right? Instead of not equal to 4, you have to put equal to 4. Instead of not a vowel, you have to put E is a vowel. The not should not be put, right? Then when you are representing symbolically, you will say not P, because y plus 4 is not equal to 4, you will say not P. And here E is not a vowel, so you will say not Q, right? What is not Q? E is not a vowel, so you'll have to put this way. Next one, symbolize a proposition. Here it's straightforward. You take the first one as P, second one as Q. There is and symbol here. And means this one, and P and Q. Next one, if two numbers are equal, then their squares are not equal. Watch here, there is not. Be careful. So two numbers are equal, you can call it as P. Their squares are not equal. You will have to say Q is squares are equal. Don't include not, right? But when you're representing in symbolic form, you'll say P. There is if then here, so it's conditional. Since there is if then, it is conditional, not Q, because squares are not equal. So not of this, not Q. If P and Q are proposition with truth values, F for false and T for true, respectively, find the truth value of this. You have to find the truth value of this particular compound proposition, not Q. Now, they have told P has F and Q as true. Remember, it's told respectively. Respectively means the first value that comes, that is false, is for P, and Q has the value true, right? So P is false and Q is true. Now you take this compound proposition. So instead of Q, what is the truth value of Q? It's T. So I'm putting T. What is the truth value of P? It's false. And here it's not Q. So I'm putting not as is. What is not true? It's false. And it's conditional false. False conditional false is true. Remember that odd combination in conditional, right? Only if it is true and false case, result is false. Everything else, it is true. All these combinations, it is true. Okay, so here it is false conditional false, which is true. Next one, Write the verbal form of the compound proposition P or Q, where P is X is an integer, Q is 5 is odd number, right? So you have two proposition, right? X is an integer and 5 is odd number. You'll have to write it in the verbal form. And basically, you'll have to join these proposition. This P and Q you need to join. How you'll join? There is OR here. So simply put OR. X is an integer, 5 is odd number, and combine it with OR. That's all. So this is the verbal form. So the last question, find the converse of the proposition. If x into x minus 2 is 0, then x is equal to 2. So you have two propositions. X into x minus 2 is equal to 0 and x is equal to 2. Right? You assume that this is P and this is Q. Look for the connections, right? If and then is the connective, right? So you need to have conditional and P conditional Q. That's all, right? So now this is a symbolic representation. I'll have to find the converse. What is the definition for converse? Converse is just swap this. Instead of P put Q and instead of Q put P like this, right? So what is Q proposition? X is equal to 2. What is P proposition? X into x minus 2. And then join them with if and then. That's all. So with this, we've come to the end of this particular topic. If you like this video, do press a like and share it. Thanks for watching.